Hello everyone, in this video I'm going to discuss what is required for your DP practical reports for the data table. Alright, so the data should be tabulated, okay, should be put into a table, formatted in Excel, not in Word. At the very end you can copy it into Word if you'd like. You can give a title and subheading description of the table, but the important part of the table is that you give the independent and dependent variable in the following format. Okay, the independent variable should be organized in ascending or descending order, but usually ascending order, as you go down in the rows. And for each trial, you should have a separate column. The dependent variable should be titled, and both the independent and dependent variable should have an estimated uncertainty with a unit. You can then calculate the average dependent variable, and finally, you're going to do just a little bit of processing for this table. You're going to calculate the uncertainty in your final column. The calculated uncertainties should either use the range method, which is the maximum value of those trials minus the minimum value divided by 2, the standard deviation, or the standard error on the mean. For each method, the remainder of the analysis should reflect the choice. Notice that you should do all of this calculation in Excel itself, okay? Do not do this in Word. This also is really important. Do not put the units in the actual cells here. The units go into the headings. So your units are in the headings of the table. After your raw data table, you may have some qualitative data or observations. These are written in paragraph form, and these include relevant or significant observations of events during the experiment. For example, if you did the ball dropping experiment outside, you might observe that rain was falling. Okay, so you can record important observations here. You can record any data that is non-numerical. So this is more obviously important in chemistry or biology sometimes, but if there is a color change or if there are pictures of what is going on, that might appear here. And finally, if there are outliers discarded in the data, then there should be a physical justification in this section showing why they're discarded. So more or less, if you've taken a data point and you know it's wrong, but the reason you know it's wrong, okay, is because of some physical explanation, then you can discard that particular outlier. If it is simply unusually high or low, but you cannot otherwise point to why it is wrong, then it should be included in your data and is reflective of your uncertainty. Then you're going to make a graph of that particular data. Notice you're not graphing each trial, you're graphing the dependent variable versus the independent variable. Most of the details on how to do this and the specifications are on the portal in the How to Excel videos, so I'm not going to dwell on everything, but notice you need that best fit line, okay, formatted appropriately. You need titles and labels and units. You should have major and minor grid lines. Your data points should be marked with X's, and you need appropriate error bars on each data point. Those data points are the averages of your values above. For the horizontal error bar, you should have an estimated uncertainty, and for the vertical error bars, you should have the calculated uncertainty from your table up here. Notice that your best fit line or curve should be taken from the physical theory. Okay, so if the physical theory implies a type of functional relationship between the different variables, like a power, exponential, polynomial relationship, then that is the function that should be plotted. Okay, and the values in the best fit equations have been rounded to an appropriate number of significant figures.